Good day, students. I hope I find you well. As I promised in the previous session that I was going to proceed to part 2 of solutions. Today I'm just going to look at the calculation part for solutions. The previous lesson we were just looking at the introduction to solutions, important terms, and we also covered what makes up solution, what should we have for us to make a solution. Today we're going to look at the calculation part. What are some of the expected calculations that we can get from this topic on solutions? But basically, when you are looking at the concentration of a solution, the definition is you are looking at how much solid you have put in a specific volume of solvent. Okay, so concentration is just an expression of how much, okay, how much solid is in a given amount of solvent. Basically, that's what we are saying when you're looking at concentration. So if a solution is highly concentrated, it means that solution has a lot of solid particles in it. And when we are looking at a solution qualitatively, by just observing it, you should be in a position to tell a person that the solution that I'm looking at is dilute. For instance, let's just imagine that you are putting maybe tea leaves or a tea bag in a transparent container. If the liquid is not deep colored, if it's light, okay, qualitatively, you can tell me that the solution is dilute. But if I add more solid particles, the liquid become dark colored. Then you are in a position to say that, okay, that solution is more concentrated. So that's qualitative analysis. There are no numbers here. You are just using your sense of sight to tell us that the solution that we are looking at is dilute, it is concentrated. Why? Because we are looking at how deep the color is. So that's a qualitative approach. But in chemistry, we also have a quantitative approach. Now, the moment you mention quantitative approach, it means there's a bit of mathematics involved. We are now being specific. We want to look at how do we express concentration, okay? So this one is a more useful description because when you are looking at qualitative, you are simply saying, it's dilute, it's concentrated. But we cannot assign numbers to qualitative analysis, but we can assign numbers to quantitative analysis. This is what we are going to be doing. Just going to look at what are some of these descriptions that we can have so that we begin to assign numbers, okay? So, more useful description is done quantitatively as follows, okay? We can have percentage by mass, okay? We can look at the percentage by mass, okay? We are looking at how much of the solid is present in a given amount of solvent, and we are going to express as a percentage by mass, okay? We could also look at percentage by volume, okay? Percentage by volume. That's another quantitative approach, okay? And we could also talk of molarity, okay? You need to be careful here. I am saying molarity, okay? Because the fourth one is known as molarity, okay? There's an L here and there's letter R in number 3, okay? So what are we talking about? Number 1 up to 4. These ones now, these give us a quantitative approach, okay? These are a quantitative approach, and as such, we could actually be asked questions on what is the percentage by mass of this solution. Express the concentration as percentage by mass. Express the concentration as percentage by volume. Express the concentration in terms of molarity. Express the concentration in terms of molarity, okay? So, the moment we have a quantitative approach, it means we should have some formulae that we can use to express number 1 up to 4, okay? Which is what we are going to do now, okay? Be aware of the fact that quantitative approach for concentration is expressed using number 1 up to 4, okay? So let us look at the useful formulae that we can have to express these quantities, okay? We'll just start by listing the formulae, and towards the end, we'll just look at some sample questions, some sample examples. So if a person say percentage, okay, just going to write in short, percentage by mass, okay, what do we mean here, okay? There is mass involved, okay? So it means you are going to look at mass of solute, okay, which is your numerator there, and you are also going to look at mass of solvent, okay, percentage, so we multiply by 100%, okay, that is very important, okay, and then a person could also say percentage by volume, percentage by volume. Now we have departed from mass, so it means we are going to look at volume, okay, volume of solute, volume of solute over volume of solvent, okay? Now in chemistry, our standard, because we say the concentration has to do with a specific volume of solvent. In chemistry, our volume is usually 1 liter, okay? That is a standard, okay? And don't forget, it's a percentage, so we multiply by 100%, okay? Now, we have done number 1, we have done number 2. Let's move on to molarity, okay? Molarity. I suppose you still remember how to calculate number of moles. So, obviously, it's molarity. Therefore, we are interested in number of moles, okay? And then 1 liter of solution, okay? So again, volume of solution, and don't forget, it's always 1 liter, okay? That's molarity, all right? Molarity, okay? You need to be in a position not to confuse the two, please, okay? This one now is number of moles again, number of moles, okay? It's number of moles of solid, okay? Forgot to add here, number of moles of solid, also here, number of moles of solute over, okay? That's where the difference comes now, okay? Over 1 kilogram of solvent. So molarity, we don't look at the volume of solution, we look at the mass of the solvent. So you need to be very, very careful, okay, when you are looking at this quantitative approach to calculating concentration of solutions, okay? So you need to have this formula in your notebook, okay, where you always refer to them before you start performing calculations, okay? Right, now we have the formula down. I hope you have understood so far. Let's just look at a few simple calculations, okay? So that we'll be in a position to appreciate what we are talking about, okay? Let's look at a solution that we have been given here. This was a question which came in one question paper I was looking at today, okay? We want to look at percentage by mass, okay? So I'm going to start by looking at the data that was supplied, okay? There was mass of solute, okay? The mass of solute was given as 3.6 grams of sodium chloride, okay? And the mass of solvent, okay, was given as 100.0 grams of H2O, okay? And we are now being asked to calculate the percentage by mass, okay? Percentage by mass, right? So percentage by mass, okay, is going to be equal to, we have our 3.6, which is our solute there. But you need to be careful now, okay? Mass of solution. Remember, we have a solute and our solvent. Last time we said to make a solution, we add these two. So we are going to say 3.6 plus 100. So mass of solution now is going to be 103.6. I add these two and then I multiply by 100. Okay? And my answer would be 3.5%. Okay? We are just being consistent here. Our final answer, we are giving it as two significant figures because the mass of the solute was also given, it was also supplied as two significant figures. Okay, and as a result, answer or final answer is going to be limited by what we have there, the mass of the solute. So, mass of solute over the mass of the solution multiplied by 100, that gives us percentage by mass of this solution. Okay, that's number one. Okay, now let's move on to molarity. Okay, we'll do molarity, and then we end the session. Okay, right. So we now move on to molarity. What was the data provided here? The data provided here was mass. Okay, mass of solute. Okay, mass of solute provided here was given as 5.10 grams. Okay, glucose C6H12O6. Okay, and obviously for us to calculate the number of moles, we are supposed to find the molar mass. I suppose you still remember how to calculate molar mass. You need your periodic table where you're going to add up all the relative atomic masses of this element, of this compound, glucose, and therefore, when you do that, you are going to get 180.16, okay, grams per mole. That's the molar mass of our glucose, okay? And we are also given volume of solution. Volume of solution, we are given our volume of solution as 100.5 ml, okay? Right, so there's something that we need to do to this volume. Our volume should always be expressed as liters, okay? So we will need to change our volume. We divide by 1,000 because 1,000 milliliters will make 1 liter. So volume of solution here should be our volume there. We need to correct here, okay? Volume of solution, okay, is going to be, we divide by 1,000, so it's going to be 0.1005 liters. Okay, right. Our formula for molarity is equal to moles of solute over the 1 liter of solution. So our solution, we have sorted it out. So we need to use these two numbers to calculate number of moles, okay? So number of moles is always equal to mass given over MR. Our mass given here is equal to 5.10 over 180.16, okay? So our number of moles, the answer I got for number of moles here was 0.0283. Okay, these are the moles of glucose. Okay, but we want to calculate, okay, molarity. Okay, so it's equal to number of moles which you have calculated over the liters that we have there. So we are going to have 0.0, okay, 283 over that number, okay, 0.1005. So we have moles at the top and then we have liters down there, okay? And when we do the calculation there, we are going to get 0.282, okay? From the formula, we can even derive the units, okay? We have moles and then we have liters as our denominator, so our answer will be like that. Okay, so we have calculated molarity of the solution there. Okay, and then just to end off, we will calculate molality. This is molarity, okay, with an R there. I hope you've managed to follow through what we're doing there. If you don't understand, you can pause the video, analyze the working, take your calculator, also follow through, especially where I was converting the ml to L, and also where I was calculating the number of moles there. You can pause and you also follow through the calculation. Okay, right. So let's move on to the last one, which is molality, and then we appreciate the quantitative approach to solutions. Okay, right. So what are we doing now, students? We are doing molality. Okay, right. Again, I'm given my solid, given, okay, NaCl. Okay, NaCl, the mass supplied is 4.5 grams. Okay, and the mass of water is given as 100, okay, grams. Okay, if you still remember the formula for molarity, we are supposed to have kilograms. Okay, so straight away we can convert our grams there to kilograms, and it becomes 0.100 kilogram, because in molarity the denominator should be kg. Okay, but our numerator should be number of moles. Okay, once again we calculate N is equal to M over MR. Okay, the mass given is 4.5. If you look at the MR for sodium chloride, if you calculate that one, it will give you 58.44. So you have your number of moles there, and if you calculate your number of moles, you are going to get 0.077 moles. Okay, and we now going to express our molality. Okay, molality, we are supposed to have our number of moles at the top, okay, 0.077, okay, moles, okay, but down here we have already converted our mass of water to kilograms, so it's going to be 0.100 kilograms, okay, and if we divide, we are going to get 0.77, and then someone may say, what is our units? At the top we have moles, okay, but at the bottom we have kilogram, okay, like that, and we have calculated molality. Okay, right, so I've just shown you how we can calculate the molarity, and also I have given you an example of calculating percentage by mass. This is a quantitative approach to concentration of solution. Remember, number one, you should remember the formula that we use, and then secondly, you look at the steps that I was following. I would encourage you, when you go through this video, to pause the video, take your pen, your calculator, and you also do the steps that I was doing so, because when you answer questions in chemistry, we expect you to show all the steps, okay? It is always important to remember the formula for calculating number of moles, because you actually saw that number of moles formula is very, very important. This was the session today. Please, if you are enjoying the videos that I'm uploading on my channel, please remember to subscribe, to share, to like, so that the information will spread, and also your colleagues will get to know about the existence of this channel. And also, as they prepare for their exams, they will also benefit from what we are covering here. Thank you. I have enjoyed teaching you this today, the quantitative approach to concentration. It is my hope that you enjoy more videos that I am going to upload in future. Thank you. Bye for now.